Alrighty. Hey, we're almost done with like the whole class. That's kind of the good news. This is video number 32, and it is chapter 10, section 3. That's an N. And it is all about the conic section called hyperbolas. And they sort of sound a little like a parabola, but they're a little different. And you know that a parabola is a U-shaped graph, right? That's a parabola, one. Well, a hyperbola is a set of two of them that face opposite directions. So a hyperbola, now this is one hyperbola, can go either that way or it can go that way. So that's another hyperbola. Okay, so similar to the ellipses, we're going to kind of break our page in half here. I'm going to draw a line down the middle of the page. We'll probably have to extend that line at some point. Oops, snap it into place. And we are going to have two different types of hyperbolas. We're going to have a horizontal hyperbola, and you should know that we have something called a transverse axis. So this is where the transverse axis is parallel to the x-axis. And when that happens, the picture, so here's your coordinate plane. The picture of the parabola in the coordinate plane, hyperbola, I'm sorry, so sorry. The picture, it would open left and right if it is horizontal. Okay, so it opens left and right. So you should know that. And there's all sorts of information about these things. And I'm going to show you how to graph them by hand. They're much easier to graph in varsity, which is the only way, because we're glossing over these pretty quickly. It's the only way that we're really going to do these. So they do have some foci in them. Well, let's do this. The vertices are here. So these are the vertices. And then foci are inside the curves. So the blue dots are foci. They're inside the curves. And let's see, we have, just like before, the vertices are A units away. There's just not enough space to put stuff in here. These are A units away from the center of the graph, right? The center of your graph in this case is center is at HK. We'll put that down here. And so that's this guy right here, HK. A is the distance a vertex is from the center. C is the distance that a focus is from the center. And then B kind of comes into play when we do these manually. So the center is HK, no matter which way it goes. The standard form of this specific hyperbola looks like x minus h quantity squared over a squared. And there's a minus in here. Now, an ellipse had a plus in there. Minus y minus k quantity squared over b squared equals 1. All right, so the only difference between that and an ellipse is the plus sign. The plus sign has an ellipse, or an ellipse has a plus sign, and the hyperbola has a minus sign. Now, if you can kind of picture the graph that I drew up here, if you took these red half circles and flipped them the other way, that would make an ellipse. They would go at each other and it would make an ellipse. So it's like an ellipse cut in half and flipped the opposite direction. All right, if we had one going this way, this one would be a vertical. We got these other things in my way. Let me get rid of these up here. Okay. So this one is a vertical. And this means the transverse axis. And the transverse axis is the distance where your vertices are. So it's from vertex to vertex. That's your transverse axis on that graph over there on the left-hand side. Okay. Vertex to vertex. That's your transverse axis. Transverse axis is parallel to the y-axis, which means this thing is going to open up and down. Okay, so this graph, I drew not very symmetric coordinate plane there. So the center would be here at 0, 0, right? That would be HK. And then your vertices would be here. And then this would be A. And then if you had foci in here, they're inside the curve. Whoa, things are moving, not where they're supposed to be. These would be foci, and that's a distance C from the center. All right, so your center, again, for this one, this doesn't change, is HK. However, the standard form does change. And this standard form is y minus k squared over a squared minus x minus h quantity squared over b squared equals 1. So similar to the ellipses, they always equal 1, right? So that is something that you should note. They always equal 1. But in this one, A is not necessarily bigger than B. A can be smaller than B. So that's important to note. It is also important to note that A comes first in the equation. So if A is under X, then this thing goes left and right. If A is under Y, then this thing goes up and down. Okay, that's the only real way that you can tell. You can't tell by the size of A. So that's something that you need to know and be aware of. All right, next. Let's see, the foci is something that you'll need. If it is horizontal, it is at H plus and minus C comma K, same as for the ellipse, actually. Foci for this guy, H comma K plus and minus C, if it's vertical. All right. The length of the transverse axis is equal to 2a. Same over here. Doesn't change. And the other axis is called the conjugate axis. That's 2b, just like it was. Conjugate. Yeah, that looked funny for a minute. Axis is 2b. And the other thing you need to know for these is that c squared equals a squared plus b squared. So that's different. In an ellipse, it was a squared minus b squared, right? And a squared was always bigger. In this one, a squared is not necessarily bigger than b squared. And I mentioned that before. And here's a couple things that you need to know. A is the distance from the center to a vertex. Okay, B is the distance from the center to a covertex, which don't really exist unless you graph these manually, which again, I'm going to show you how to do. And then C is the distance from the center to a focus. And remember, that's singular for foci, which is plural. Okay, so let's graph one of these things. We'll go to a new page, and we are going to graph. And you will actually want to have some graph paper for these and a ruler because they're very, very specific. And if you try to sketch out a graph and you don't have it on a coordinate plane with exactly square boxes, it's going to cause a problem. So we're going to go x minus 2 quantity squared over 4 minus y plus 3 quantity squared over 25 equals 1. So here's some stuff we want to know. We want to know where is the center. Remember, that's HK. We want to know what is A squared and what direction is it going in. What is B squared and what direction is it going in. And once you know that, that's actually enough to... Oh, we also probably should know the orientation. Okay, so here is what we know. Because the x comes first, the orientation, is horizontal. Okay, and that's the only reason is because the x comes first. The a squared also always comes first. So this is the a squared, this is the b squared. So we know a squared is 4, and because it's under x, it's going to go left and right. If a squared is 4, then a is 2. B squared is 25. It's under the y, so it's going to go up and down. And if b squared is 25, then b is 5. And our center is going to be positive 2, negative 3. Okay? Here's where your graph paper is going to come into play. All right. So we're going to plot the center. I'll do that in green. 2, negative 3. Now we're going to go left and right, just like in an ellipse. Left and right, 2 units, and plot them. And then we're going to go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, that's convenient. 5. Okay, now what you're going to do with those, instead of drawing an ellipse, is you are going to draw a dotted line or dashed line, whatever you want to consider that. Draw a dotted line box to connect the 4 dots. Okay, so I'm going to actually use a dotted line here. I'm going to have to change one of these. Okay. Let me get some properties. I want to change that. Hopefully that works, what I just did. I don't know. Am I going to have... Okay, good. That works. All right, so I'm going to go dotted lines all the way down to here. Dotted lines across. Dotted lines up here. And the reason you're making dotted lines are because this rectangle is helping you to form your hyperbola. The hyperbola is the graph, and the graph is solid lines. But anything else that's on your actual graph that's not the graph itself should be dotted lines. So that is why we are using dotted lines to do that. Okay, now what you're going to do after you do that, so those are guidelines. Your next step is to connect. Is that the right word I want? No, it's not. Now you're going to draw dotted lines, or again, dashed lines, with arrows on each end. Diagonally through the box. These create asymptotes. asymptotes, asymptotes, that form the hyperbola curve. Hyperbolic. Okay, so I'm going to do this in a different color. We'll get this guy. So I'm going to extend these out. When you do this, you should go a ways past the actual box itself. But I have to go like click on it and do that. So you're going to connect the corners through the center, and then extend these out. So you want to go quite a ways so you can create the curve. And make sure you go corner, center, corner. Okay. And then once you do that, all right, what's our orientation? Our orientation is horizontal. So these points right here that we used, those are our vertices on the left and right side. Okay, so when we went left and right, these are our vertices. And we're going to actually hit those. And you can also hit the box when you draw in your curve, but you're not going to hit the dotted lines, the green ones in my case. So my hyperbola is going to be super fat and wide, and it's going to look like that. And you're just going to kind of sketch in an approximation that looks very similar to that. And that's what your hyperbola would look like. So the black part is the hyperbola. The pink box helps you create your asymptotes. If I was really mean, there are actual formulas that you can generate those asymptotes with, and they're just a pain in the rear end. It's easier just to draw the box in there and do it. So there are more algebraic ways to come up with those asymptotes. And I could also have you come up with the like the y equals mx plus b equation for those asymptotes. You're welcome. I'm not doing that. And then, so that's the way you can do that. All right. Now, we're going to do one more, and then I'll show you what they look like. We'll do a really straightforward one in varsity, just so you can see how you're going to actually graph that thing. And that might take me a moment because I don't have it set up or brought up in varsity, but we'll show you how to do one. All right, we're going to do another equation, and we're going to graph x squared, or I'm sorry, 16x squared minus 9y squared equals 144. Now, remember, these equations must equal 1. So if they don't, you have to force it to equal 1 by division. Okay, so we're going to divide by 144, divide by 144, divide by 144. And when we do that, this thing's going to simplify down to x squared over 9 minus y squared over 16 equals 1. Now, I should have done one that had an orientation that was vertical, but I didn't. So this one also has an orientation that is horizontal. X comes first, so our a squared is 9. A is going to go left and right, and a is 3. Our b squared is 16, which means b is 4, which means b goes up and down. And our center in this case, because there is nothing with our x squared or y squared term, our center is going to be at 0, 0. And so let me throw a graph in here. I scroll down just a teeny bit. All right, so our center is at 0, 0. And our A is going to go 1, 2, 3, 1, 2, 3. Our B is going to go up and down 4, 1, 2, 3, 4, 1, 2, 3, 4. Now remember, these 2 points, the black ones here, will actually be our vertices. Our hyperbola is going to hit those. Let's get some lines in here. We'll do our pink lines. I'm going to make sure they... Okay. So we'll have dotted lines here, down, across, and up. And then I'm going to go with my asymptotes, corner through the center, corner, and off the graph. Corner. Now you're going to do that with a ruler because freehanding these are ridiculous, but I have very straight lines, right? They drag as straight lines. So I have the ability to do that. And then I'm going to take these and extend these up higher. Kind of goes through the equation there, but that's okay. Extend these up higher. The longer your line goes, whoops, the easier it is to see where your hyperbola is going to be formed. All right, and then I'm going to use a black pen to actually make my hyperbola. So remember, it can hit the box, but it can't hit the green lines. It can hit the box, but it can't hit the green lines. Okay, so that's how that would look. All right, let's go take a quick look at varsity. Oh, I don't even have varsity open. All right. Varsity, PreCalc. This is I don't have it open for you guys yet. Chapter 10, conic sections. Scroll down a little bit. Ellipses. Keep going. Hyperbolas, 10.3. All right, so we'll just take a quick look at a problem. All right, so actually, this is the problem we just did, very close to the problem we just did. So notice down at the bottom, you have some tools here: parabolas, circle, ellipse, hyperbolas. You need to pick if it is a vertical, opens up and down, or a horizontal, opens left and right, hyperbola. This guy, x squared over 4, y squared over 9. So x squared comes first, so it is going to be a horizontal hyperbola. So I'm going to pick the right tool and then start at your center. So I know this thing's going to start at 0, 0. So I'm just going to put a point there. And then I'm going to go drag out 2, because if I take the root of 4, that's 2. So my A is going to be 2. And my y, I'm going to then drag up 3. And I'm just dragging. I'm not clicking anywhere. My y is going to be, or my b squared is 3. So my b is going to be, my b squared is 9. So my b is going to be 3. So once I get drug here, I'm going to click. And when you get this 4-way white arrow, that's when you have drugged this thing into the right place. And then you can drag off the graph. And then you can submit. So you don't really have to make the box. You can see the asymptotes. That's what the dotted lines are, but you don't see the box in here. Okay. Let's see what number 2 looks like. All right. That one's very similar, except it's going to be a vertical one instead of horizontal. Let's check out number 3. That's like the one I just did a moment ago where it's not equal to 1, so you have to divide. This one's similar. Again, you have to do some division. All right, this guy is already in standard form. Let's see if there's a vertical one. I just want you to see a vertical one because we haven't. Oh, perfect. Okay, so this one's vertical. So we know the y is first, so it's going to go up and down. So we're going to pick that tool. And then you want to find your center. So that's going to be, now, don't be fooled, right? It's not HK. The H always goes with the X. So this is going to be 3, -1. So 3, -1. Click on your center. And then my Y, my A squared is going to go up 1. So I'm going to go up 1. And then my B squared is 4, which means I'm going to go left and right 2. And so that guy is going to go there and I'll be done with that, right? Okay, so remember, think about that. This value here is your a squared. A squared's 1. The root of that's still 1. And that's going up and down because the y goes up and down, which is why I only went up 1 unit from the center. Okay. And then my b squared is 4, which means b is 2. So I'm going to go over 2 from the center or from the where I drug up. And then that's why that's going to be that. So that should be the resulting hyperbola from that equation. Let's just submit, make sure we're good. Okay, we'll get a green. And then I think 7, 8, and 9 are in general form. And so we will need to, we need to now go and address the general form in our notes. So let's do that and take a look. Okay, so we're back here. New page. All right. And we have one short example here, and then we are almost done. All right. So I'm going to put that in there, and we'll do this. Put 4x squared minus 16y squared plus 16x minus 64y minus 64 equals 0 into standard form. Okay, so here's the deal. Again, recall that the general form is ax squared plus by squared plus dx plus ey plus f equals 0. However, in a hyperbola, a can equal b, or they can be different values, but their signs must be different. And that's how you know, looking at it, that it's a hyperbola. Remember, in a circle, a had to equal b. So just for review, in a circle, a had to equal b. In an ellipse, a could not equal b, but their signs were the same. And then in a hyperbola, it doesn't really matter what the value of a is. A can equal b, a can, oops, that's not an a. I hate when it does that. Hyperbola. A can equal b, a could not equal b, but regardless, their signs must be different. Okay, so that's how you can tell. And you can see up here, they are actually different numbers. One's a 4 and one's a 16, but the x squared term is positive and the y squared term is negative. Now, the process is going to be exactly the same as what we've done before. So we're going to start by grouping our x terms together. So let's do that here. Let me get a different color pen. We're going to group the x terms together. So we have 4x squared plus 16x. Put a plus in there. Your y squared is minus 16y squared minus 64y. And then remember, your constant is always going to the other side. So I'm just going to do that in step 1. Okay, so group the x's, group the y's. That's step 1. Move the constant. You should pretty much be pros at this by now. And then in this next step, we're going to factor out only the numeric GCF. So we're going to take a 4 out of here, leaving us an x squared plus 4x. We're going to add our blank. Here we're going to take out the negative, well, actually it's the leading coefficient is what you're factoring out. So we're going to take out a negative 16, giving us a y squared plus a 4y plus a blank equals 64 plus a blank. Now this one is actually going to be minus a blank, right? Because we're taking a negative 16 and multiplying it by that blank. So this sign is the only thing that's different in this one. So this step is you're factoring out the leading coefficient. And add blanks. And make sure that this second blank is a minus a blank because of this negative that's being pulled out. And it's possible if your first coefficient, the x squared, is negative, it might be this first one that's going to be negative. But one of these blanks is going to be negative and one's going to be positive on the right-hand side. Okay, that is always going to happen. All right, next. Remember that, so that your next step is to fill in the blanks on the left. And that's done with 1/2 of b squared. So half of 4 is 2. Squared is 4. So that's going here. But remember, we have to multiply 4 by 4. So that's a 16 over here. Here we're also doing half of 4. So that's 2 squared, which is going here. So that's 4. But now it's negative 16 times 4, which is a 64. All right. So now we have got, all right, we're going to turn your trinomials into binomials. And remember, we're doing, so that's this guy is turning into x plus 2 quantity squared. Make sure your coefficient stays on. Minus 16 y plus 2. And then on the right-hand side, we're just doing the math. Your 64s are going to cancel each other out, giving you a 16. And then our last step here is going to be to divide by the right side. So we need to divide by 16, divide by 16, divide by 16. So that's going to be a 4. That's going to cancel and be a 1. That's going to cancel and be a 1. So we have x plus 2 quantity squared over 4 minus y. Oh, I forgot a squared there. Y plus 2 quantity squared over 1 equals 1. And this would be the standard form. And if that's all you were doing, that would be your statement there. If you now had to graph that, the only way you could have graphed that is to put it in that form, right? So that was your goal. That's the only one of those I'm going to do. They're time consuming and you've had practice. The only change here is this negative. Now, remember, it could be this first term that's negative. And if you want to, the thing that you might want to do is so here's a hint. If the x squared term is negative, is the negative term put your y grouping first. So what I mean by that is do your y squared plus your by squared plus dx plus ey plus a blank, and then it would be minus, I need a eraser. And then, well, actually I don't need an eraser. Then you'd have plus, you'd have your minus your ax squared plus your dx plus a blank, and then move your constant over to the other side, right? So put your y's first, if positive, and then put your x's second, if negative. And I'm talking only about this ax squared term. That's the important one. So the by squared would be positive, the ax squared would be negative. That way it's in exactly the same format. And then when you get your standard form, it's your y that's up here in the first place where you need it, and your x is over there. Okay? That might happen in varsity. It might not. I don't really know. All right. And then there's one last problem that you're going to have. And it says something, oops, not that. It says something like this. Write the equation. So this is like the last problems of the ellipse homework. With the center at 0, 0, a focus at 5, 0, and a vertex at 2, 0. Okay, so the best thing that you could do, hint, sketch. Right? So here's some information they give you. Center, 0, 0. Focus, 5, 0. Well, that's 1, 2, 3, 4, 5. Well, if a focus is left and right, that tells you your orientation is horizontal, which is important because now I know that my standard form is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. And I know I've got to fill in some certain things. I need to know h and k, which are the center, which are 0, 0. So I already know that. So I can come back and now say it's going to be x squared over a squared minus y squared over b squared equals 1. So now I need a squared and b squared. All right, well, maybe I already have some information. I know, okay, let's go back. So this was my focus at 5, 0, which means if this is a focus, that's C, right? Okay, so we'll use that information. And a vertex at 2, 0. If that's a vertex, that means that's A. So if I square A, so A equals 2, so A squared equals 4, and that can go under here. And then we had this formula, c squared equals a squared plus b squared for a hyperbola, not a squared minus b squared. That was for an ellipse. Well, I know c is 5, right? C was 5. So c squared is 25 equals 4 plus b squared. So I subtract off 4, so 21 equals b squared. And that can go here. So that's that. So this is the equation of the hyperbola given that information. And you don't have to draw it. You don't have to do anything with it. You just have to find the equation. And that's how you would do that. Okay? So that should give you enough information about a hyperbola to sketch them, put them from general form to standard form, and then go about manipulating the equations a little bit, given some information. So we have just parabolas left. Alrighty, toodaloo.